This form of a circle equation is known as the standard form. And honestly, we love standard form because we're able to read so much from it. Immediately, this tells us that our center is at 3 and -6, and that our radius was the square root of 10. Standard form allows us to just quickly jump in there and obtain information. Now, unfortunately, we don't always get it in this format. This statement is also equivalent to this one. Now, let's take a look at this. What has happened here, and I'll show it to you in a second, is we've basically multiplied these binomials out and gathered like terms and done things. But this is just known as the general form. The issue with it is that, like, we can't say, oh, I know where this circle is centered and what its radius is. So the goal is for me to help you to go from this thing into this thing. But let's show you where this came from. So this guy's general. Here's how it came about. And you can see what happened. So here's the form we like, known as standard form. And what we did is we multiplied out, all of that together. We multiplied this together to get these items. This grouped up a little bit. This grouped up a little bit. There was a 9 and a 36 that we could group. And then we finally moved that 10 over to give us this value. Now, ultimately, all that is just a whole lot of multiplication and stuff to get us here. Now, getting here is multiplying, okay? Going backwards is a process we call completing the square. And the idea of that name, just so you know where that name comes from, to complete a square, is we want to take things and put them into perfect squares. Do you see how this says x minus 3 squared? It doesn't say that here. This says y plus 6 squared. These are known as perfect squares. So I'm going to teach you a process that takes a lot of loose things and puts them together in a completed square. Basically, this is the journey that we want to be able to do. Go from general through a process to obtain what we call the standard form. Let's show you this process. To learn the process, we are going to reverse it. In other words, let's start with a perfect square and undo them. In other words, let's break them into their pieces and see if there's a pattern in that. So when I multiply this out, I get x squared plus 3x plus 3x plus 9. I get x squared plus 6x plus 9. We'll come back and look for patterns here. I get x squared minus 8x minus 8x plus 64. This simplifies to x squared minus 16x plus 64. And the last one, I get x squared plus 7x plus 7x plus 49. And I get x squared plus 14x plus 49. Now, it's at this moment that we begin to ask the question of patterns. Is there a way, if I was in this world, how would I know how to back up to this world? And there is definitely ways to do this. So let's highlight a couple things I want us to focus on. I want us to focus on the middle number and its partner, the constant. The middle number and the constant. The middle number and its constant. And my question to you is, if we had this information, is there a way to connect, and we'll call that B, because often we, in a situation like this, a quadratic, this middle term, the linear term is often B, and this is often C. Let's take a moment to look. How can we relate 6 and 9, negative 16, and 64, and 14 and 49? And you can kind of see how, if I go back one layer, there is a connection between that 8 making 16 and that 8 making a 64. And what it is it's the middle term, the b term. 6 divided by 2 is 3, and 3 squared is our 9. And negative 16 divided by 2 is negative 8, and negative 8 squared is 64. And half of 14 is 7, and 7 squared would be 49. So what we're learning is that if you have a trinomial here, and you want it to be a perfect square, and we're dealing just with lead coefficients of 1 at this stage, but what we're doing is you would take half of b and square it to obtain c. So we can start to ask if some of these are or are not perfect, right? So how do we test if they're perfect? Well, if they're perfect, half of this number squared would give us this one. Half of 2 is 1, and 1 squared is 1. That's not a 1, so this is not a perfect square. Half of 6 is 3, and 3 squared is 9. This is a perfect square. Half of 4 is 2, and 2 squared is 4. This is a perfect square. Let's look at a couple others. X squared plus 10x plus 25. Is this a perfect square? Yes, because half of 10 is 5, and 5 squared is 25. Is, let's see, this guy. Is this a perfect square? Half of negative 4 is negative 2, and negative 2 squared is 4. So we can begin to see how we're starting to learn how to create perfect squares. And if we can create them, then we can complete them. So why don't we try? What numbers would go into these spots to make perfect squares, or begin the process of completing a square? Well, we learned that half of 12 would be 6. 6 squared, we would put a 36 in that spot. Negative 6 divided by 2 is negative 3, and negative 3 squared, we would put a 9 in that spot. This one will cause us a little bit of pain, but it's okay. Half of 9 is 4.5, or 9 halves, and that squared would be 81 fourths. Now, you may not like writing 81 fourths in there, but also we can just find out what 4.5 squared actually is. And we get, sorry, my calculator fell here, 20.25. Now, just so you know, not every number is going to be even like the other cases. And so odds will create a fraction, but you can just simply use the decimal equivalent for those. All right, let's actually do the process. So first, let me ask you the question, is this a perfect square? And I think your answer is going to be no, because if I take half of negative 10, I get negative 5 squared is 25. So this is not a perfect square. So guess what? We are going to complete it. So the process of completing it is basically putting the number that we want there. We want to put a certain number in there to make it a perfect square. Now, you know enough about equations that I can't just throw a number into an equation and walk away. I've got to balance that. So a couple of things you'll notice that I did. One, I got the 14 out of the way. Over here it was plus 14. I moved it to the other side so I could put my perfect number in. And so that's why it's negative 14. And now I'm looking for what number goes here. Now you know this, right? Half of this is negative 5. Negative 5 squared happens to be 25. So I'm going to drop the 25 right where I want it. There it is, right in its spot. And what have I done? I have made a perfect square. And now I'm able to wrap that up in its perfect form, its completed form, which is x minus 5 all squared. And where does the 11 come from? Well, it is what is made on this side. This is known as completing a square. So we say, is this a perfect one? And we say no, because half of 8 is 4, 4 squared is 16. So what you and I would do is we would put that perfect 16 right where we wanted it. We would move the 1 to the other side, but we would add a 16 to that side as well. Why did we do this? Well, because this simplifies to the perfect square x plus 4, and we get a 17 on this side. This is called completing the square. We have put it into a perfect square format. Looking at this closely, this number is not what it should be. When we take half of 2, we get 1, and 1 squared would be 1. So we want to put the 1 right where it should go. There is where we want it. We move the 13 to the other side, and we have to add 1 to both sides. But this is just x plus 1 all squared and minus 12. This is called completing our square. One more of these before we get ready for our circle. I guess first of all, you'll notice things have been moved around a little bit here. And actually it's okay the way it is, because I need to put in the perfect number, which would be divide by 2 is 5, 5 squared is 25. The 14 was already out of the way. But again, remembering, if I make 25, I have to put it back. And so this would be y plus 5 all squared equals 39, right? One thing students will often ask is, like, when do I know that, this is a positive or a negative? And the answer is when you take half of this number, it will tell you. If this is plus 10, so half of that would be plus 5. If this was negative 10, you would divide by 2 and you get negative 5 would be the value. All right, we're ready to attack the original problem, which is how do we complete the square to help us get the equation of a circle. All right, let's go to the original issue of why we learned how to complete the square. This is an equation of a circle in its general form. We found out that that's not very helpful. We don't know the radius, we don't know the centers, and so we needed to complete the square. Now what I want you to notice is there's kind of 2 squares that need to be completed, one about the x's and one about the y's. And so we're going to actually complete the square twice. So I'm going to kind of do it step by step. Take a look here. So what I'm saying that we need to do is we need to find the perfect number to complete this square. We need to find that perfect number to complete this square. And notice what I did with my 35. I just got it to the other side. That's why it's negative. And then I'm going to drop in a number here and a number here. And that's completing the square twice to do this. So you know that half of negative 6 is negative 3, and that squared is 9. Half of 12 is 6, and 6 squared is 36, and I had to add those over here as well. And bingo! What looked to be pretty complex isn't that bad. This guy here all becomes this guy, and this guy here all becomes this guy. And these numbers, whatever they are, all tally to this. Now, here's the good news. What's the center? Hey, my center is 3 and negative 6, and my radius is the square root of 10. All right, let's do it. So I need to complete this square. Half of 4 is 2. 2 squared is 4. I need to complete this square. Half of negative 2 is negative 1. Negative 1 squared is 1. I'm going to move the 8 to the other side. And I made a 4, and I made a 1. Let's double check to make sure you're clear on what I did. So half of this number is 2, and that number squared is 4. Half of this number is negative 1, and negative 1 squared is 1. And when I make numbers like these ones, I have to add it on the other side as well. Why is this positive? Because I moved that to the other side. And now, look, I'm done. X plus 2 squared, y minus 1 squared, 12, 13, and our answer is negative 2, and 1 is our center, and our radius is the square root of 13. Ooh, I love this stuff. Let's do one last one. Now sometimes things aren't organized the way we want them, so let's do that. X squared, let's bring the 8x over to this side, making it minus 8x. We have y squared, let's bring the negative 10 over y over to the other side, which would be plus 10y. And we can leave the negative 10 on that side. So this had an extra step. Things were kind of really mixed up. I moved the 8x over, making it negative 8x. I moved the negative 10y over, making it plus 10y. And I just left the constant over there because that's where I eventually want it. So you know what to do. We are going to take half of negative 8 and square that. So negative 4 squared is 16. There's one of our numbers. We are going to take half of 10y, which is 5y, and square that. That's a 25. We made that. And now we have a negative 10 and a 16 and a 25. And I think now we can write this out as x minus 4 squared, y plus 5 squared. What does that all add up to? I think 31, 40, yeah, 31. And so our center is at 4 and negative 5 with a radius of the square root of 31. Woohoo! Love completing the square. Enjoy this, friends.